Hi everybody, welcome to section 3, classification. In this section, we are going to take a look at brief information for classification problems, and also we will talk about some of the most common classification algorithms like KNN, logistic regression, naive Bayes, decision trees, and also we will make some simple applications about classification algorithms in R. Welcome to KNN. In this video, we're gonna take a look at brief information about the classification tasks, and then we will talk about introduction to KNN, and finally we will make simple applications of KNN in R. Well, the classification is a problem for identifying categories based on a training set of data. In this problem, there needs to be labeled variables. For example, detecting an email is spam or not spam is one of the classification problem. Also, predicting the gender of an e-commerce website user according to their behaviors is also a classification problem. Well, let's talk about the KNN algorithm. The KNN or K-nearest neighbor algorithm is one of the basic learning algorithms and is a learning method in which data is classified based on the label data. More specifically, the distance between the observed and unobserved data is calculated via distance functions. These functions are distance measurements such as Euclidean distance and Manhattan distance. Well, in this part, we are gonna apply KNN to a sample dataset. The dataset is about the diabetes. And in this example, we will get dataset from a website. Because of that, first of all, we need to define the URL. And then by using grid.table function, we could import data to R directly. Let's check the first 6 rows of data. You could see that there are 9 columns. And then let's assign the column names of the data. And let's check it again. And you could see that we have put the column names successfully to our dataset. Well, let's check the count of the labels, and also we can check the proportions of the labels. As you see that 65% of the label set is 0 and the rest of it is 1. Well, let's get the row numbers and let's check it. And as you see that we have 768 rows in our dataset. Let's get the column and let's check it. And as you see that we have 9 columns. And before building a classification model, and it's better idea to normalize the numerical variable. And because of that, we are gonna make some applications in this part. Well, in this part, we are gonna calculate the mean variables of each column, but accept labeled column, because you know just first 8 columns is numeric and our last column is about our labels. Okay, well, to do this, we could use apply function, and also we could put our dataset, which are numeric, and because we would like to make calculation for each column, we put 2 here, and because we would like to calculate the mean, we are putting mean function here. Let's check the results. As you see that the average for age is about 33, and also for BMI is about 32. Let's calculate this standard deviation for each column. It's so similar to mean variables for each column also. And let's check it. As you see that the standard deviation for age is about 12, for BMI is about 8. Well, let's set a null matrix because we will use this matrix in our calculation for normalization procedure. And in this part, we have 2 for loops, and also we will calculate the normalized variable for each rows according their columns mean and standard deviation. Okay, and then let's merge the normalized variable and our label set, and let's get the summary of our data set. This summary is about just normalized numerical variable. And also in classification task, also in machine learning tasks, you need to divide your dataset at least into two parts, which are train and test parts. And usually, the researcher divide 70% of their dataset into a train and the rest of it into a test set. Well, also we will do the same for this application. We will define the train size and then test size, and let's create our train set and test set. And we need to install some specific packages for specific tasks. For applying KNN in R, you could use class packages. If you have not installed it before, you could kindly do this by using install.package function. And because I have installed it before, I will just call the library now. And well, let's train our model because we have already to do this. And to train KNN model, you could use KNN function, and also you need to define your train set and test set. Also, you need to define your labeled column, and also you need to define K. In this example, I will define it as 5, but also you could change it if you don't be happy with the result of your model. Well, we have completed the training process of KNN, and then let's draw a plot of the results, which includes our predicted and real values.